Hi all. See this problem comes in the year 2019 where we talk about the area bounded by the given curves and the given region. So first we have to understand the given curve, right? So here every curve is not complicated. Only the function x into x plus 1 that is complicated. So here let us try to observe that curve, right? So let us consider the function fx, which is equal to x into mod x plus 1. So that gives me that x squared plus 1 if x is greater than equal to 0, and it will have minus x squared plus 1 when x is less than 0. That's the definition of this function. So therefore we can see that the left hand side of y less than that curve will change its value, or the changes the pattern of the function in the different ranges. So minus 1 to 0, 0 to 1, right? So first understand that what is x squared plus 1. So therefore that curve x square plus 1 will be definitely looks like that. It will intersect the curve here and goes up like it's a part of a parabola. And the next one will be downwards, right? It is because the coefficient is actually the downward. So basically we are trying to draw the curve x square plus 1 on parabola, and this is x square minus 1, the bottom curve. And then they say it's the area. So this is the shaded region between minus 1 to 1. That's area we need to find out. So here our main job is to first solve this kind of problem, that how to identify that appropriate graph. So generally we can easily draw that with parabola, hyperbola and all that stuff. So these are already known, right? So basically our final plot doesn't have this part. So this is the shaded region. Now we can see that obviously the shaded area is the bounded by the curve and the x-axis. So we don't have to spend that much time, right? That's a very easy problem. So let's go ahead and understand the curve, right? So this is the shaded area we are talking about. Now let's go ahead and find out the area. So here the equation when x is greater than 1, it gives me that 1 plus x square, and this area is obviously a1, and the other side is actually 1 minus x square, and it is a2. Okay, this is obviously they will intersect at the point 0 to 1. So this is x equal to 0, it will be x is equal to 1, this is x is equal to minus 1, right? So therefore we can easily say that the shaded area is actually the area of a1 plus a2. But see that we don't know, they may be symmetric, they may not be, right? So better to understand that, because we are not sure 100%ly, okay? But because by visualization it's not looks like that, okay? So it's better to calculate that a1 and a2 separately. Let's go ahead and calculate that. So what is a1? The a1 is obviously obtained by the integration x equal to 0 to 1. Then we have 1 plus x square. Now if I calculate that, this limit is very easy to calculate. Let's substitute the appropriate values. So therefore after integration it's x plus x cubed divided by 3, which gives me 0 to 1. That means I think 4 by 3. So therefore it gives me that 1 plus 1 by 3, which is 4 by 3. So therefore the area whatever we calculated, that is 4 by 3. Now we need to find out the area A2. So what is the area A2? A2 is actually integration 1 minus x square, but only the difference is that in this case our integration comes from minus 1 to 0. So minus 1 to 0. Let's do that integration. So therefore x minus x cubed divided by 3, and we have to do the integration from 0 to minus 1. That means that if I substitute 0, we get 0, minus if I substitute minus 1 plus 1 by 3. That gives me that 1 minus 1 by 3. That gives me actually 2 by 3. So therefore, we can easily understand that this is the area of the triangle area. So therefore, the total area A is equal to A1 plus A2. That gives me that 4 by 3 plus 2 by 3, and that's why it's 2. So that's why for this particular problem, the area of the shaded region is the option A, and the correct option is D. And that's it. Hope you understood the problem. Thank you.